Good morning, everyone. Welcome to another TBC Power Hour. Today, with all the news or drones in the news lately, we decided we're going to talk about UASMaster workflows and TBC. So, myself, Riley Smith, and Stephen Ostrowski is with me today, and we're going to be presenting to you on these workflows. So, a little bit of background about myself. A few of you may have heard this voice before on some previous Power Hours, but I work with the Trimble Business Center group in product management, and here in Colorado, Westminster, Colorado, I should say. Steve, maybe you can introduce yourself.
Yeah, I'm Steve Ostrowski, and I've been with Trimble for about a year and a half. I come from Ohio State and have a little bit of a background with actually writing an article on comparing the different UAS softwares, or I guess photogrammetry softwares. So hopefully I can give you guys a good demonstration here.
Perfect. Hang on. So kind of agenda for today, we're going to look at some of the specific applications that are applicable to you as UAS users with photogrammetry, as well as how and why we implemented a UASMaster and TBC workflow and how that integration works and the mechanics, the workflow itself, and a kind of an idea of what you can expect while going through that workflow, the benefits of that, why UASMaster is a good software for doing these photogrammetric applications, and then Steve is going to jump into a demonstration on showing how that workflow goes and some of the key items within UASMaster that you need to know. And then we'll sum it up at the end and save some time for a Q&A period. As well, as we're going through the presentation, feel free to enter any questions you have into the chat window or any comments, and Steve and I will get to your questions as soon as we can. So jumping into it, looking at some of the applications, one of the first ones to look at is the topographic survey, being able to collect that necessary feature information for as-built and topographic boundary information, things like that, as well as going into the mapping and GIS side of things, getting that necessary feature information and being able to catalog it. Project and route planning, which is a really key element for UAS applications, as route planning generally takes long corridors, so it's not necessarily small projects. So UAS applications or UAS units are able to help with that long stretch of information, collecting that data in long strips. Volumetrics and quantity surveys. UAS sensors are great for this, in the fact that generally in volume or areas that require volumes and quantities, there's a lot of high traffic and generally some safety concerns. So being able to use an unmanned vehicle to collect that data is a kind of a key priority. Land use planning, cataloging what certain applications the land is being used for, such as farming, agricultural, urban, and things like that, and being able for urban municipalities to plan how they're going to develop the outskirts of the cities and things like that. Going into environmental assessment, cataloging vegetation, the changes in vegetation, whether that's a short period, long periods of time, as well. That kind of ties into monitoring, as well as collecting data over different varying periods of time to assess the changes, and whether that's just the topography or environmental or various other factors. So our motivation for integrating UASMaster with TBC in a new photogrammetry workflow is that when we implemented TBC aerial photogrammetry module, we were tailoring it towards the land surveyors who were getting into the photogrammetry and learning how to use UAS units in their workflows, how to efficiently use them as well. And so we implemented more of a simple approach, and with that, making an easier transition for those surveyors to get into the photogrammetry. But now, as over the past few years, technology has changed quite a bit, and software is improving, as well as the UAS units themselves are improving, being easier to use. Those land surveyors and professionals are becoming more adept to using that type of data in that software, and so we're transitioning them into UASMaster, which is generally tailored towards the photogrammetry professional, but now we're kind of the merging of those two professions and closing that gap between the two. So some benefits of why is this good for you as a user, whether you're a surveyor or a photogrammetric professional. So processing in UASMaster allows for, allows to process any UAS data. We had a struggle with TBC because we were only able to, or challenge with TBC because we were only able to process Trimble UAS units, while with UASMaster we can use any UAS data. As well, UASMaster has quite a wide variety of advanced tools in editing for photogrammetric applications. TBC was kind of simple, straightforward on with our tools, and now with UASMaster we have a lot of enhanced abilities in that way, as well as you can integrate that data into TBC. So anything you generate in UASMaster, such as a point cloud or an orthomosaic, can be integrated back into TBC with your regular RTK, total station, and other survey data. And then finally, an improved processing and deliverable creation time in UASMaster. We found in tests that the processing speed, as well as the creation of point clouds and orthomosaics, is a lot more efficient in UASMaster than TBC. So the mechanics of how this works.
Just hold 1 second. Excuse me. I think people are not seeing our screen. Let's see. Steven just said that he logged out and in again, and now I see the slide. So.
So if anyone's having any issues,
if anyone's having problems, message me, and it seems like people are seeing it now. So.
Okay.
Ignore.
Yeah. If anyone else is finding that there's some technical difficulties, please let us know, and we can make sure to fix that right away. So jumping back into the presentation, looking at the mechanics of how this works, I know a few of you are wondering, okay, so how do I use UASMaster with TBC now? How does this apply to me? So with UASMaster, this has been a standalone software package for photogrammetry for quite a while, as well as info. We have the info suite, which has a lot of other high-end photogrammetry application packages. But with UASMaster, it's a standalone software, so it can be purchased by itself if you are interested in only photogrammetry and not what TBC has to offer. But with the new TBC aerial photogrammetry workflow, we have an integration of both the software. So instead of having just TBC with the existing workflow, which we are still keeping, this existing aerial photogrammetry workflow, we now install UASMaster with TBC aerial photogrammetry module at no extra cost to the user. Now diving into the workflows, Steve is going to talk a little bit more about these in depth in the demonstration, but a higher view. So with the current workflow we have set up using Trimble UAS data, you go out, collect your UAS data in the field, you go into TBC, import that data, set up your project, process any trajectories you have, and then use the send to UASMaster command to get that data into UASMaster, perform adjustments such as your relative and absolute adjustments, and then generate your deliverables like point clouds and orthomosaics. And then finally take that data and integrate it back in with survey data inside of TBC. Now looking at non-Trimble UAS units, so the workflow is similar but with an added element to it. So you can still go out in the field, collect your UAS data, but now with any UAS system, whether that's an EB or a DJI or anything that you as a user are comfortable with. In TBC, you set up your project, your coordinate system, import your GCP points or process any trajectory data you have, and then combine from those two, from the UAS data and from the TBC into UASMaster, where you set up your specific sensor from that non-Trimble UAS unit, which is generally your camera sensor, as well as then you go through the steps of performing the adjustments and generating those required deliverables like you would in the previous workflow, and then finally integrating that back into TBC. So I've kind of droned on and on about...
was that your pun?
He got it. I've drone on and on about and talked enough about UASMaster, so now Steve is going to get into the meat and bones of this presentation and show us some cool stuff on the workflow.
All right, thank you, Riley. We were going to start with actually showing you the Trimble UAS workflow, but we actually found out we don't really have that much time, and hopefully we're going to be moving through this fairly quickly. It should be very elementary, but or at least the simplest workflow we can provide you, but hopefully everyone can follow along. So your first step is to start a project like any TBC project. Set the units. We'll be working in a metric today, and then as is always good practice, we're going to want to save this project. And I guess while we're waiting for it to work through and catch up with the network, with the inclusion of UASMaster, we gain a lot of advantages. TBC will not have the ability to not only have faster and better processing of photogrammetry data, but that means, therefore, we'll have better and faster products. It'll also have, UASMaster also has advanced point cloud editing and classification capabilities, as well as basic CAD abilities. So now that the project seems to be setting up, we'll save it. I will just use this as a test project so I can delete it later.
So one of the questions that came up, Steve, while you're setting up the project there, was what version of TBC is this new workflow applicable to? So UASMaster is included with the TBC aerial photogrammetry module as of version 3.80, which was released in November of this year.
And so this is the next important step, and this is setting of your coordinate system within TBC. You can actually start and run a project within UASMaster, bring your products in, set your coordinate system there, but we do not encourage that, as it can be, you can import incorrect data. So we set everything in TBC and then send it to UASMaster, but that's more of a workflow for advanced settings. So I changed the coordinate system to Croatian coordinate system that we got from one of our customers. That's where the data came in from the EB. I will next import the GCPs. We can import these GCPs within UASMaster, but we can also do it here in TBC if we wanted to process them, if they were raw data or anything like that.
So do you typically have a GCP file in the form of a CSV, or is there other methods that we get that file?
It really depends on how you collect it. So anything that you can take a measurement out in the field where you fly your project, and then you could even write it down from your RTK chain assist if that's what you if that's the workflow you're doing.
Perfect.
So apologize. Next time we'll just have this set up.
All right, so we're importing some GCPs. Okay.
So that's actually after setting, saving the project, setting the coordinate system, and importing any data. With a third-party UAS, that's where TBC in the beginning actually is done, because we can't import images and we can't import a camera model. So then we will move to the photogrammetry ribbon here, and as you can see, those are the coordinate points, and we will use the new send to UASMaster command. Opening it up again, you can see within this command, it'll prompt you, ask you if the coordinate system is correct. This is just to ensure that you are set up correctly, because once you export to UASMaster and perform an adjustment, create deliverables, you may not change it until you're back into TBC, and that can cause some coordinate system problems. So our next option is to add any flight missions. Since this is a third-party UAS, we do not have any flight missions created from JXL, so we will add the ground control points. You can either, you have a couple options with how you select, but we'll select everything because that's the only data we have. And then click OK. This will automatically open up UASMaster. and it'll prompt you to save a project, and the connection is now made between the two projects. So. Give it a second.
One of the questions that came up was in regards to the GCP that Brandon asked is, does it matter if it's a text file or does it need to be a CSV?
It's anything that TBC can import, and they can import text files. So.
Yeah, so either or is the answer to that. Another question that was asked is from Ben was, is there demo sets available? And I believe on the info UASMaster Trimble website, you can log on there, and there is a tab on that web page that says examples, and there is a data set that's provided, as well as some YouTube videos that go over how to import and work with that data set in UASMaster.
Yes, and I would suggest to look through. They have a tutorial step there, walking you through step by step, explaining all the tools that we can't cover here today. And there was also videos on YouTube that you should watch as well if you get stuck at any point. So here's the project preparation. I will then go to the edit button, which is actually going to set up my project import screen. So this is actually the UAS project editor. I view this as where you import all your information. If we were using a Trimble UAS, all this information would actually be inputted because the JXL would have that information already there. So the first step is to set our camera parameters. These are your camera model. This camera model, since it is new from a third party, we will name it. And then for branding, we have to select custom. If you had one of these other UASs, you could select that and the parameters would be filled out. But because we're using a brand new third party UAS, we should select that, and it'll open up our camera model. This information is actually stored within the images. So if you go back to the images, you should be able to select and actually find a lot of the interior parameters. When I refer to interior and exterior parameters, the interior parameters are kind of the mechanics and measurements within the camera and how it goes from your lens to your sensor. So we're projecting from a 3D world to a 2D plane back to a 3D world, but we're working with triangles essentially. So finding those measurements to have the relation. So we can see that the image here is 4,000 by 3,000 in pixels, and then our focal length is 5 millimeters. So move out of that, and we'll remember some of that information. So here is the sensor width, and then height. This is your orientation of your platform. This is for your roll, pitch, and yaw that you would enter. For DG, these are we found to be at 90 degrees, but for this UAS, it's actually still at 0. Now is usually where most people have difficulties in finding their information. So this is the focal length, which we can find in the properties. But then if you go to the pixel size, we know this is 1.87. And the reason we found this was because if you either look in the camera manual or online, you can find decent sources. We do not give you these parameters for every different type of camera, simply because they do change. We actually encourage a calibration every time you do run a project because the interior measurements are so small that these parameters will adjust every time that if there's a hard landing or anything of that sort.
So can I find most camera models out there on this website?
This website is a good source to do it, and I would say, yeah, essentially for any digital camera, this is a good place to check. So this is the Canon PowerShot. This is what we could find also in those properties of seeing which camera we're using. And if you scroll down, you can see different parameters, and we're looking for the pixel pitch here, which is 1.87, and it will actually tell you how that's calculated within the other parameters. The next input we need is the image coordinate system. If your orientation, when we look at it again and we double check the import of the images, if they're wrong, you would actually change this. Sometimes they're offset by 90 degrees, and in which case you would change the coordinate system axis for this. And then you would add in principal point of auto calibration is 0, 0, and let the calibration adjust for that.
So that principal point of collimation, so when I run a calibration procedure in UASMaster, it's going to update that field? after it runs?
Yeah, it'll give you, after you run a calibration within UASMaster, it'll create another camera model where these values are actually filled out more accurately with the calculations. You only need the sensor size and focal length for the camera parameters to begin with, and then we can perform calibrations to get the rest of this these parameters.
And then let's say I treat my UAS unit very good, which we all do, right, I hope. Then can I reuse that camera model that I've set up in other projects as I go forward?
Yeah, you would actually import that, and I'll talk about that here in a second down at the bottom. You still want to calibrate, but you may import other camera calibrations from previous projects. The GNSS IMU would be the next information. This would be the lever arm offset from your GNSS measurements to the image center. For most third-party UASs, this is already adjusted for, and it really only matters if the GNSS data you have is accurate enough to be smaller than that lever arm. So it's usually not something you have to worry about, but it could be something you see in your products, and you may want to check later. The next would be your distortion coefficients. This is where you would enter your radial and tangential distortion effects from the lens. There's a lot of values, they're very small, and they help to pretty much adjust for any inaccuracies when projecting from the center to the radial part of the image. But again, this is not information you need. When you calibrate the camera within UASMaster, this information will be propagated. You can then put any comments you have about this model that you want to, I guess, remember about, and the parameters that you filled in here. And then if you wanted to, down here at the bottom, by clicking the import, you can actually navigate to another project where you use the same camera and bring in that calibration. Since this is a dry run, we'll pretend this is the first time we've done it and not import any calibration data. So right now I'm done with the camera model, and I'm ready to move on to actually import the images and import their exterior orientation parameters, or the images, GPS, and IMU coordinates, or measurements. So then I move to the frame type, and I double-click that, and that allows me to import the image directory by going to import image files, and then add a directory. This allows me to import all the images at once. Do not import the exterior orientation here, actually. You've seen that. So here's my image directory. I'd select that. My next step is actually to enter in the terrain height. This is the average GCP elevation that you should enter in. So just look at essentially what's a roundabout number, what's the average of the GCPs that you have.
So if I have a varying height, like it's a mountainous area or anything like that, is there like a recommended way I should come up with that terrain height?
That's where you want the which part of the project you want to process to. So that's why that variable rate is able to put in. So if you want to calculate the bottom of a pit, you should use that. If you're only using, if you only have ground control points at the top of that pit and you really want to process for the bottom of it, you should actually use the bottom of the pit elevation.
Okay.
So the next step is actually how you index your image or name them. This information is red, so this is the root of the file, and then the naming is at the end here. You would select any of these 4 different kind of naming methods to do it. I like to use any character and then actually count every space to index the name, and this allows us to match the exterior orientation that we will do later, match that information to each other. So all data or all images were imported correctly, hit finish, and now it'll say, oh no, we don't have any GNSS IMU data for these images. We'll add that next. So we'll click OK, and now the images are added. Our next step is actually to add the GNSS IMU or initial exterior orientation parameters. We're going to pretend that we only have images and we were not given a CSV to actually do this with. So we're going to go to Tools and EXIF to GPS. Tool, this reads the EXIF information from the images, and we have to navigate to the image directory again, and then produces it in whatever coordinate system you like and makes it a text file. So it's a nice tool to have if you don't have a text file created from your third-party or UAS. So I'm going to set my coordinate system just so I know. The EXIF information is usually always stored in WGS84. This tool allows you to transform it to any coordinate system you like, but I typically just keep it in WGS84 so that when I import it again within the project editor, I know what coordinate system that data is in.
A question that came up from, excuse me, Abdul was, I have TBC Survey Advanced, and will this be a separate module? Yes, so this is a separate module. It's called the TBC Aerial Photogrammetry module. There is a part number that enables you to upgrade your TBC Survey Advanced and add on that photogrammetry module to it. So you'll maintain all the features of Survey Advanced, but you'll get all the photogrammetry additional features. Photogrammetry module on its own has, if you just purchase that module, it has TBC Complete capabilities as well as all the photogrammetry capabilities on top of it.
So right now I'm saving the text file that I will create of the exterior orientation parameters. I'll save it on my desktop. Hopefully be able to find it again. So click OK, and it should be created. When I go back to the project editor, I can now go to the GNSS IMU and import it. I need to navigate to that file location up here at the top, and I need to actually change this to all files so that I can view that file I just created. Since it is just a file type, it's not actually saved as a text file. And this will import that information. We need to then set the import parameters. So this information starts at row 4, which I'll set. It will also actually list the grouping separators. Our grouping separators is for the stripper information or the flight lines. That's actually no longer necessary information to be imported, but it is automatically generated here, so we'll use it so it can display. Here again, it's just showing you to make sure how to import it correctly, whether or not it's a comma or not. And then I need to assign the parameters to each column. All right, and here again is how my naming index that I need to match. So I will use the same one I used last time. And all images now have GNSS coordinates. I need to, again, this is what I was talking about with setting the coordinate system for the data that we're tying to the images, which we saved as and set as a WGS84. And this is for the strip information, which we can then again see is imported correctly. Finish.
So with GNSS data, if it's from a third-party or non-Trimble UAS unit, let's say it's some kind of post-process, like a PPK data set, where would I process that, or how would I get that processed to import into UASMaster?
You would process it hopefully in TBC.
Yeah. So if it's a readable file format such as a RINEX file, it can be processed in TBC. If it is in some specific proprietary format from that specific drone distributor, then that might have to be processed in another package. It really depends. It's kind of situational in that case. But if it's a basic GNSS format such as a RINEX file, that can be processed in TBC.
And here within that GNSS and IMU information, we can set the standard deviation of the measurements. The defaults are about 10 meters and 6 degrees and 20 degrees for Kappa. If you have a post-processed solution, depending on the accuracy of that GNSS data, you might even import down to somewhere down the size of 5 centimeters. Be careful on how you adjust, and we have a little more to do with this in processing later, but these are settings that you might need to apply as well if you have high-quality GNSS data. So everything should be applied, and right now our project is actually set up. If you look at the frame type, you can see that the GNSS data is actually brought in and attached to those images. Right now is actually, if you were using a Trimble UAS, you would be done, and all this information would already be imported. So now would be the workflow that would start with a Trimble UAS. Again, if I click on the coordinate system, I can see that I cannot change this project because it is tied to a TBC project. It is going to make you stay in that coordinate system that you had set earlier. and then I would save. So the next part would be we would start the processing on this UAS data. I'm actually going to switch to another project where this has been completed, so we don't have to wait for the type point extraction or the relative adjustment and absolute adjustment. So bring that up. So the first step we'd want to do is actually create and actually check the import of our data. And to do that, we would create a project overview by selecting the image commander tools and looking in process at project overview. This is kind of a quick way where the images are just collaged together over top to make sure that the import was done correctly. I'm actually going to skip this step because it is taking a little bit of time to process through, but this would just collage the images and show them displayed here. You may also want to look at the orientation by zooming in. By doing this step, if you have if the image coordinate system is actually imported incorrectly, you could change the orientation so that it does look like the project or the area you're flying.
So a question that came up was Abdul asked, he has an EB-RTK unit, and he's wondering if the workflow is the same or if there's any differences on the GNSS side of things. So I think with the GNSS side of things, depending on the format of that RTK data, it can be processed in TBC, but I don't know firsthand what that file format is that's coming from an EB in regards to GNSS. Steve, do you have any?
I do not. I would assume that wherever you can process their information, they probably either TBC or they provide a software can do it, would process it, and then you would it would create a text file. So you would just skip the access to GPS tool and move right into just adding that data into the GNSS IMU.
Abdul, if you want some more information, feel free to reach out to myself, to me, and we can, and maybe if you have a file type, we can take a look at it together and see if we can come to a conclusion on that. Another question that was asked by Ariel is there the ability to use a local system in UASMaster?
Yeah, anything that you can set in TBC, you can actually just transfer it to UASMaster, and it'll actually set the coordinate system with all the parameters. And if you look at the bones of how the transfer is made, you can see those calculations. Now that we're still waiting on this, I'll actually walk you through the setup of UASMaster and the georeferencing page here. So this is where you perform your relative measured ground control point and then your absolute adjustment with a camera calibration. These steps are pretty much sequential. You have different strategies to actually, and depending on data, improve your processing speed. You can select some ground control points, and this will actually speed up your type point extraction because it gives the software better initial estimates for its optimization problem. But our first step would be to extract type points. But before that, let's see if I can actually show you this. So this is showing you a topographic view of all the images that you imported. If I select over to the pane on the left, you can see points, photos, and any other photos. If I highlight all the images and activate them, I can zoom in and actually see the orientation of those images to again ensure that it looks like they were imported correctly. And looking at it and that roundabout, I can definitely see that they were. So I can assume that after that my images were imported correctly. Maybe my parameters weren't, and you won't be able to see that until you actually perform a calibration to see how poor those were. But my next step would be to extract type points. This is just a sequential, simple workflow. You can, again, actually measure ground control points first. The more advanced you become with UASMaster and the more familiar you are with your data, you can actually set your own workflow, which is very nice. But for the beginner, this is a good workflow. We suggest that you stick with the default, and that is the half resolution, so the resolution being 1:1 for full and 1:4 for low resolution on the matching ability. For bad images, you would use a low resolution. And then if you have GNSS data, this is pretty much using it as I guess, a weight in the calculation. If you do not click it, it still needs those initial estimates, but it will not use the weighted estimates. We'll leave that on for this data. Our next step, and it's actually what is really cool about UASMaster, is measuring ground control points. You will find that this will speed up your processing time and your time on the computer. Yeah, it does take some time for the software to run, but your actual time on the computer will be cut probably even more than in half. So if I go to, let's say, A79, you can see I have 8 predictions of where this ground control point is in 8 different images. We'll see how quickly I can select it, obviously, with waiting for the software a little bit.
Again, the question got asked, Chad this time. He asked about tutorials being available for UASMaster. There is, Steve's actually done a great job and created a few tutorials on using non-Trimble UAS data within UASMaster. I think this data set is actually one of the ones you've created a video from.
Yeah,
right?
And that will be available online. There are currently, right now, as we speak, there's a UASMaster tutorial that you can actually download data from the info website and then use their tutorial to walk step by step and explain each tool a little more in depth. And then there are also YouTube videos available now as well. And then we have a few YouTube videos actually showing the entire workflow of TBC to UASMaster. We don't go through the georeferencing as there are already videos available for that as well. So if I click here, we can see that there are 3 measurement types. I'm in manual. There's a manual, semi-automatic, and fully automatic. Semi-automatic, pretty much when you click on every GCP point, it uses the least squares to compare each image so that it actually goes subpixel and makes the selection of that GCP more accurate. Manual would just be you click and that's the measurement. And then we have fully automatic, which can really improve your processing time. If I click on in one of the images as a fully automatic, it'll go through and actually compare that little box to every other image where it estimates where the ground control point is, and hopefully give you a good measurement point. If you don't have good initial values, it'll probably not come back very well because it doesn't know where it's searching for the point. But if you select a few ground control points in a couple images, process and extract high points, and then go back and do this step again, it should be able to, in most cases, find most ground control points fairly quickly. And this is a huge improvement over TBC, where you had to select each ground control point individually, which took some time.
So what is the software doing in those 4 images? How does it determine the position in the other images?
So it's pretty much just image processing. It's looking at that rectangle there and the value of each pixel, and then it comes up with a matching area. So as you can see, we have a couple bad images actually with that image. So it's saying here on the left that it matched to that area, which is not the case. So
how would I remedy that? So that
I would actually, before I do anything, I would just select another point where it matched well, because the orientation parameters or the initial estimate should be good enough. And then if that didn't work, usually every time there'll be 1 or 2 images that don't match completely correctly. I would switch to manual measurement after I do this, and then just click on each image where the actual ground control point is.
Perfect. One of the points brought up by Thomas was that there is monthly online training programs that can be ordered from Trimble. They're 2-day trainer-led programs. So if that is something you're interested in learning more about UASMaster and the workflows within it, you can contact Trimble, and we can set those up for you.
So usually using a good mixture of fully automatic matching and manual matching along with semi-automatic will speed up your processing time pretty immensely. So here we can see it actually didn't estimate this point. It went back to not being able to match in this image, so this image probably doesn't look like the ground control point in most other images, which is why it failed. I would manually match that, and then you can see the blue X's are actual measurements. I would move to the next set of images and make sure that everything is matching there. Let's see. In all actuality, if I were to collect this data, I would want to have targets out in the field, simply because matching to the center of a manhole in the street is usually not the most accurate way to select a ground control point, and that does affect the accuracy of the products we're giving back to it. But beggars can't be choosers in data. So we're done actually with that fairly quickly in selecting all those points. And when not on a webinar, this software here in TBC does run quite a bit faster. But again, we move on. So after we select all the ground control points we would like, and you can see in this project I've selected a few just relatively well spaced throughout the project. We would then compute the exterior orientations or perform a calibration. This is known as your absolute adjustment. So your first step would be to perform with a new camera that does not have, without a distortion model, which you know we did not bring in. We have to perform a first approximation adjustment here. We would first perform that first approximation. This would give us the distortion model, and then with every other camera, you would then perform an extensive calibration, and that would give you pretty much very high accurate camera calibration parameters. You can also, if you want to readjust, or if you want to readjust the calibration parameters, but you don't want to change anything, it's only necessary for remeasurements. You would use the adjustment only, but this is not typical in most workflows. And again, you can apply the weights for the GNSS and IMU measurements, as well as if you want to go back and for the advanced users, restore the exterior orientation parameters, you can do that as well, but that is not needed. So we'd perform our first approximation adjustment, and then our extensive adjustment, and we'd be finished. After that, we would create and view our calibration report, which is pretty similar to TBC's now. You can see the standard deviations for the image locations as well as the ground control points. It'll give you your camera calibration parameters and tell you the performance of the calibration you just did, as well as what you can expect out of the accuracy of the products you'll create. So by scrolling through here, we can see an outline of the project, an overview of the images of the project we just created, strip information and tie points. Right there you can see how many tie points are within the project, and as we move down you can see your camera calibration and even further the image residuals, which are fairly decent, your block adjustment, which are actually sub 10 centimeters, which is good, and the exterior orientation, standard deviations, and ground control point accuracies, which you can see are all pretty good. This will tell you if the calibration you just performed was out of whack. If you see one ground control point is pretty far away from the accuracy of the other ones, you would probably remeasure that, and you probably selected the wrong point. So that makes it's a good check again after the calibration. So after processing, we're kind of done with the photogrammetry part. We would then create and move on to producing our deliverables, which in the georeferencing is where you're doing your relative and absolute adjustment, and then you would create your point clouds and DEMs in the surface and ortho generation tab.
So this is where I create all the stuff that kind of my end products.
Yeah, that you'd want to bring back into TBC. And this is actually where the huge advantage in UASMaster is, because it has so many editing tools and point clouds, and has a variety of products to create. So I would suggest, and we won't be able to obviously cover that here today, but it is something that is very powerful within UASMaster, should be looked at. So it'll pop open the screen, or should. here in a second. It'll ask you what type of products you want to create.
So this is a separate window from the one you're in before?
Yeah,
okay.
So it opens up a new window for product generation. My first step would be to generate a point cloud, a DTM or DSM. A DTM is the surface without any objects, and a DSM would be a surface including man-made objects on top. Within the DTM, you can select smooth, detailed, or smoother. This is going to pretty much take out any objects that aren't ground level. Again, what type of deliverable you're looking for, you would put the setting as that. If you only want just ground information, you would use the smoother. DSM, again, you would want to select, it depends on the product you want to create, either if you want a dense or very dense, it takes a lot more time, but it would be a lot more accurate or a lot more points, sorry, not accurate, a lot more points within that point cloud. But after that, you could then, after you create the point cloud, you'd be able to create an orthomosaic of those products. The pixel size entry field is in the point cloud manager, should represent the ground sample distance and can be found in the calibration report we just did, or really most times you're running a flight, you would know the ground sample distance because that would be the product you want to create and have it deliverable with that. So it'd be kind of one of the, I guess, details that would be specified in the product that you're going to be handing back. But you could set that to any value, but pretty much keep it around the ground sample distance.
So where can I find the ground sample distance?
Before you run your project, you would want an idea of the ground sample distance you want when you're collecting data. You wouldn't just slide in an arbitrary elevation, so you would have an idea of that beforehand. But it's still in the camera calibration PDF that we just created as well, and you can actually calculate it with pretty much based on the height of the flight as well as the focal length and pixel size. But you don't need to calculate it. You can actually go back and look in the PDF again.
Yeah, okay, so it's in that report.
Mm-hmm.
Okay, perfect.
And if you set it at the lowest increment, you would just get a resolution based on that interpolated. So then you create an orthomosaic, a classic ortho, which does not check for occlusions, a quick ortho, which is just a fast orthomosaic, and a true ortho, which checks the data for occlusion and uses the object shapes together with the DTM. Or you could create from the point cloud, which is created with the DSM and uses color from the point cloud to make a quick ortho photomosaic. But that would be how you would create all your products. And you could actually, after you create the point cloud, you would want to typically go back in and within this view, actually use all the powerful tools that UASMaster has in editing the point cloud you just created, and before you even create your ortho photo. So we will not touch on that today, but UASMaster does offer a lot of ability within that to edit the point cloud that you're making. But we'll assume now that we're done because we're almost out of time anyway. So
what's a couple tools though that I can use in UASMaster for point cloud? Like some useful things.
You can edit, delete, you can classify. It has a great 3D viewer, and as well as drawing simple CAD lines. So
I can do like classify by vegetation and ground and things like that.
Yeah.
Oh, perfect.
So it is quite nice and quite quick to use actually, and you'd be able to look at, say, the outline of a roof and actually edit so that it does match the image so that you do get a good CAD line and good elevation data. So the next step would just be simply to send data back to TBC after we created our products. To do that, you do a project, send to TBC, and it'll bring up a window asking you which products you would like to send back. We want to send back everything, and then it'll actually even send back the ground control points again and the vector observations from each image, so you can actually import that again, kind of like you see in TBC now, currently with the Trimble UAS workflow. And you want to set the quality of the points you're sending back as either survey, mapping, or unknown, so that those standard deviations can be applied in TBC. This is the next step, is sending what classification from the point cloud we want to send back. We're going to send back everything because we didn't classify anything, and then the grid width or resolution of it. So it's going to pop up. It's going to create those products in a folder, and within the UASMaster project folder, you can actually navigate and see where they're located. It says TBC data, and it'll work through this process of creating that, copying them, giving you a couple of check marks, and then you just simply hit send, and it'll pop up in that TBC project that you've already started, and you can accept them and then continue on your way with using those deliverables and any other TBC workflow that you'd like to do.
So while we're sending data right now, there's quite a few questions that have come up in the past 10 or 20 minutes. Let's see. Let's start with. So yeah. Okay. So any advice, Steve? You might be able to give some advice here on improving the point quality or the point cloud quality for buildings. So if I'm flying over an urban area and I'm generating a point cloud, is there any recommended tips for getting the best point cloud? Whether that's a field procedure or maybe
for buildings, it really depends. I mean, if you want to improve your quality, you take more images over the area that'll improve your matching quality. You can then edit. Hopefully, with more images, you'll be able to match more points and more images, improving their accuracy. You then actually want to edit within TBC or within UASMaster those elevations, because usually large changes in elevation you can see in the point cloud aren't always accurate. It's a hard area for the software to estimate. So you would then edit the point cloud there so that you would get a better point cloud generated for that building. And usually once I show you within TBC, and actually maybe I even have it already loaded up, you can actually see these are products that I've actually created too before. When I look at my 3D field, and if I turn on my scans.
So this data is from that project?
Yeah, it's from the project, but okay. It's taking quite a bit of time, and I know we are running out of time. So we'll see it pop up when it is done creating it.
So there was a question earlier on about exporting for format. So if you send the data back to TBC, you can export the point cloud in any existing export format that we have in TBC, such as E57 or LAS, and a few other types that we have in there. As well, for surfaces and things like that, they can be created from the point cloud in TBC and exported as a land XML. A recommended setting that we've just found for we were just talking previously about the buildings. A good field procedure for collecting the UAS data in an urban canyon kind of area for buildings is getting about 85% overlap both forward and side. So 85 and 85 on both ways.
All right, and it will pop up, but it will actually prompt me to accept the data I've been sent back. As everything has seemed to take a little bit of time here, it'll actually prompt me to do that here in a second too as well. But looking at this point cloud, you can see that it actually does a pretty good job with buildings already. There are some areas that we'd want to adjust for, but it's a pretty accurate point cloud and orthophoto that we would create just from without even editing. Obviously, that's still necessary and something we'd want to do if that was something you really wanted to model was that building. But just looking at it as a land cover, it would be certainly good enough for that.
Perfect.
So that actually completes the workflow. Hopefully we can get that. Yeah. Selection.
Another question that came up was, can I use data from or imagery from Dell AirTech and drones? Is there really a limit on the manufacturer?
No, there's no limit on manufacturer. It's just as long as you can get those initial camera parameters or your focal length and sensor size, which it will be usually provided in the properties of the images, you can use any third-party UAS to process with. Obviously, GoPro or something with a line scan or fisheye view would not do well or is suggested. So just as long as it's a standard, usually CCD frame camera, it should be able to process in UASMaster. But after the import, and you can view and actually just pull these into any other TBC workflows you would like to do. You, of course, would want to go through the next steps of editing your point clouds before you send them back to TBC, but As you can see, it's pretty easy, and with that straightforward workflow, you can get done. If you know, especially your first project will take some time, at least getting the parameters set correctly and calibrating correctly, but after you have that step done and you become a little more familiar with editing within UASMaster, you can get a project done very quickly. You can process very quickly in UASMaster.
All right, perfect. Well, thanks, Steve, for that demonstration. I can see there's a lot of questions that have come up in regards to it, and then some of the good feedback we have from others. So just to quickly sum it up before we jump into the question period, we'll just give you a few helpful links and tips. So if you are interested, if you're not an existing TBC or UASMaster user and you are interested, you can contact your local Trimble dealer and get a 30-day demo license for both products. As well, there's 2 links here on the PowerPoint that provide downloads to those products as well. There is tutorials for TBC. We have quite an extensive list of tutorials. 2 of those tutorials go over UX5 HP workflows within TBC, as well as we'll be in the future going forward making more tutorials organized around the TBC UASMaster workflow. And as I mentioned before, Steve has been creating some great videos that we're going to post on YouTube that go over the workflow that we went over today, a couple of non-Trimble UAS units as well as Trimble UAS units, and those will be posted on YouTube. As well on YouTube, there is already some great videos regarding TBC and UASMaster. There is a TBC survey channel as well as a Trimble geospatial channel, and there's tons of great videos there. So that kind of wraps up. There's a couple quick links I have here. So Steve did bring up the digital camera database webpage where you can find a lot of information for your sensors. So that's great when you're setting up your non-Trimble UAS sensors within UASMaster. As well, if you're just you just want to know more about photogrammetry in general, I recommend going to the ISPRS website, International Society for Photogrammetry and Remote Sensing, and you can learn a lot more about just the general photogrammetry science itself. And so now we're going to jump into some QA. I think, Steve, you've got a couple questions that you've picked out already here.
So you can import, I think it was Daniel from Sweden, you can import that CSV file within UASMaster. Thomas, who actually works with UASMaster, wanted us to point out too that you can install patches from UASMaster. They're constantly improving and making sure that the products that they produce are better, and you can install that from info.
Yeah.
But it will not overwrite
TBC.
the TBC.
Yeah. So with updates and things like that. So if UASMaster comes out with a new version, you can install that version and it won't affect your existing install of TBC. It'll work the same. As well, it works opposite as well with TBC. You can install a new version of TBC or update TBC and it won't affect your new your UASMaster version.
And Chase, yes, you can add additional tie points that you select. And UASMaster actually even lets you view them in stereo, which is really cool and makes the selection a lot more accurate. So if you have an area that's sparse or grassy and it's just nothing's really tying together there, you can do that manually. I am actually not sure. Stephen asked what is the maximum number of images UASMaster will handle. It is very large. The software can handle a lot of imaging and it processes very quickly. With the project we had here, which is about 50. I think it's upwards of hundreds or even thousands. It'll run very quickly. Yeah. And I mean, obviously that will take overnight, but it will still process very large data sets.
Yeah, I did see a data set. I think it was 60 kilometers squared at one point in time, something quite large. So the capabilities are pretty unlimited almost with UASMaster. Yeah. So I don't think we're really limited on the number of images.
They give you a simple workflow, but it's actually very powerful photogrammetry software. We hope to just make it simple though for people who just want to go in from TBC and aren't familiar with it and create a product and send it back. And then Chase also asked, if you select smoother DTM point cloud, how will that affect the accuracy and resolution of the OTHR photo? Again, it's just going to take out elevations that it deems aren't within the algorithm, aren't on ground. So yeah, you might not get, I guess, man-made objects that are you might not see that 2 meter by 2 meter electrical box if it processes it out, but you're selecting that because you just want the ground information. That's why you select a DTM anyways.
Another question that was asked earlier, I don't remember who exactly asked it, but they asked if the photogrammetry module that's with Trimble Business Center is also available with the heavy civil edition of Trimble Business Center. And that is, yeah, the answer to that is yes, it is the same. There is a module for that, for the BC HCE version of Trimble Business Center, and it has the same capabilities as well as includes UASMaster as the TBC aerial photogrammetry module.
And Mike asked, when you send the data back to TBC, is there a file type created, or is the file type still using the same? So when you send data to UASMaster, there's an XML created, which links the projects and sends all the information over. It's kind of even like a JXL, it's on images and camera parameters, but also file locations. When you send it back to TBC, again, yes, there is a text file created telling TBC where those products are, and you can find that as well as called, I think, send to TBC, but the data is created and saved in a folder, but it will just prompt you to accept the information that comes back, and it should pop up. How much is the standalone software for UASMaster?
So yeah, for pricing and things like that, you'll have to contact your local Trimble dealer because the pricing can vary for UASMaster and TBC regionally. So I recommend anyone who's interested in it, contact your local dealer. And as well, that dealer can provide some demo licenses for the software so you can test it out and give it a run before you make any purchases.
And it is always a good idea to create a point cloud as dense as possible when you are doing that. If you just want to make sure that you're processing, or if you just want to use it quickly, you can create a small one. But if you're going to make a deliverable, take the time to create it correctly. Zach asked, can we import and generate deliverables for photos without GPS locations? Yeah, you can process without them. They would not be accurate or referenced. How do you get a bare earth model? Does the software do any automatic point classification? From Steve. I'm actually not too sure on that.
So Steve, I believe with UASMaster you generate the point cloud, and you have some tools for extracting different layers out of that point cloud, such as vegetation and ground and things like that. So there will be a layer that extracted out of that point cloud that is a ground layer. It's not necessarily, it might not necessarily be the bare earth model you're referring to. If there is some additional information you could provide, we might be able to better answer that question.
There's how does Craig asked, how does UASMaster work with Windows 10? I believe it is all right. You'd want to check the PC standards for what we want to operate on UASMaster on, because it is the powerful software that does need some processing power, but it works pretty well on any.
So one of the questions that came up earlier was about the processing power for your laptop or your desktop computer. So some of the recommended settings are to have a dual processor system. I believe, what is that, 12 or more cores each processor, depending on I mean, it's a good idea too to understand the kind of projects that you're handling as well, and the amount of photos. A good amount of RAM is necessary, not a small, so I recommend 16 or 32 at least. Yeah. And then a 8 gig graphics card would be best to operate it at a high efficiency.
All right, and then there's a question from, so for orientation, I do not have to select GNSS IMU. You do not, if you do not select that when doing the type point extraction or for orientation, it just will not use those weights. If you have good information, it is a good idea to use that, and it'll constrain the products that you're creating and the matches to actually the location of those images instead of only using ground control points. If you have poor data or poor GNSS and IMU data, then don't use it. If you have high accuracy GNSS and IMU data for the image locations, then yes, use it. Can we create a DTM from a DSM already created from Chris? I believe you have to create them independently. And then.
So one of the other statements that was made by a user here is that, just as an example, was Jose processed 1,700 images in one project with UASMaster. So thanks for that information, because that's good for everyone else to know that you can process such a large data set.
It looks like you can do a batch processing, which will give you a coarse and just fast deliverable, but it is not up to enough quality to actually be used. So you do not want to process without GNSS. You want to at least have a coarse position of where it's at, so you can have initial estimations to create the product.
So you're saying if I just have imagery, I can't do a processing. I have to have some GNSS positions.
Yeah.
Okay.
And then Matthew asked, when creating the process project overview, Ortho, what GSD do you recommend for quick overview? I would just use 0.3 or whatever the standard that's already there. As this isn't a product you're going to create, you just want to make sure that you're importing the data correctly. Just if it takes, I would just use, not even use a high GSD. I would use 10 or 0.3, I think is what it's set as default, because you just want to process it quickly to make sure your images are orientated correctly. If it's taking too long, cancel it and then select something higher.
So a good question that was asked by Velo. Sorry if I'm butchering any names, I apologize. Require asking an estimate of how the difference in speed between TBC and UASMaster. So I don't know, Steve, have you processed two data sets in both those packs?
Yeah, so I actually ran through last night because using the project that I was showing you here today, I actually imported, deleted some things I shouldn't have, so I just processed it and ran it through in actually less than an hour for all ground control point selections, relative and absolute, and product creation even. It's only 50 images, and we haven't done a time test between the two, but it does, because you're able to select ground control points first and then do type point extraction and actually change your workflow around, you can improve it quite quickly. That's not even including the time you're saved by simply the ground control point selection in UASMaster is much better as
so
well.
Not only the processing speed, but just in general the automated tools that we have. All right, so we'll take maybe one more question. We're kind of 10 minutes over already, so we'll take one more, and then if anyone else has some questions that Steve and I did not get to, please feel free to reach out to me. My contact information was at the start of this presentation, and as well, if you just have some good suggestions, maybe in regards to this power hour or maybe future power hours, I'm definitely open to hearing them. So we'll take maybe one or two more.
And Chris asked, can you multiple flights be merged and processed from a UX5 HP? And the answer is yes, you can actually import. You have the ability to import multiple flight missions from TBC to UASMaster.
All right, perfect. Well, thanks everyone. Thanks Steve for doing this power hour. You did a great job, and a lot of good information here on this new TBC UASMaster workflow. Once again, if there is any additional questions that you have, feel free to reach out to me. And as well, one thing to note, we do have a Trimble community website, which is somewhat of a forum, and UASMaster topics and TBC topics are answered as quickly as we can get to them. So if you do have any questions, or you're going through the workflows with the software and you're wondering maybe how you can improve your workflow or some tips and tricks, feel free to post any questions on that Trimble community webpage. So you can go on, just Google Trimble community and create an account and then use that. So thanks to Steve, and thanks to everyone here who attended, and we'll be seeing you next month. Cheers.